Hi everyone! In this video we're going to go over a few practice problems for assigning R and S to different molecules. So let's start with a challenge problem. I'm going to draw a molecule where we have a central carbon and it has 4 different bonds. So on the top, it's bonded to fluorine, and then we have chlorine in the back, OH in the front, and then a methyl group off to the left. So I would like you to try to assign R or S to this molecule. So remember from our previous videos, we had to first assign priority to each of the substituents based on atomic mass. So whatever has the highest atomic mass gets first priority, and then we just go down from there. So feel free to pause the video and try this on your own, and then we'll go over it together. All right. Let's go over this problem together. So let's assign priorities. So which of the groups or atoms that are directly attached to carbon, which of those atoms has the highest mass? So does fluorine have the highest mass, chlorine, oxygen, or carbon? Remember, this is a methyl group off to the left. Chlorine has the highest mass, so chlorine is priority 1. What has the second highest mass? Fluorine, oxygen, or carbon? Fluorine. All right, what comes next? Oxygen or carbon? Oxygen. And last but not least is carbon. All right, so let's write our assignments next to each group. Okay, so now we have to assign R or S to this molecule. So normally we would draw a circle from 1 to 2 to 3. However, our first priority atom, chlorine, is in the back. So this is going to be kind of difficult to assign. So if you come across this situation where your lowest priority group is either in the plane of the paper or in front, coming out towards you, so in a wedge position, you want to rotate the molecule so that it's actually in the back. So what we're going to do is actually turn the molecule slightly so that when we're viewing the molecule, the methyl group is in the back. So we're just going to turn these bonds so that CH3 is in a dashed position. So I'm going to redraw the molecule. So fluorine stays on top, but if we shift everything around so that CH3 is in the back, chlorine is now coming forward, and OH will be in the plane of the paper. And one helpful thing to do here is to build this using a modeling kit, and then you can physically rotate the bonds and see how they can change position based on your viewpoint. Okay, so now let's number our groups again. All right, so CH3 is in the back, which is perfect. This will make it much easier to assign R or S. So we're just going to draw a circle from 1 to 2 to 3. And if we imagine this is a steering wheel, we're turning it to the left. So we're going in a counterclockwise direction. So would that be R or S? S. So remember, S stands for sinister, which is associated with left. Okay. Now let's do another practice problem. All right, so for this problem, I'm going to ask you to try to draw 1R, 2S, 1 bromo, 2 chloro, cyclohexane. Now, what I would encourage you to do first is just focus on the last part of the name. So try to draw 1 bromo, 2 chloro, cyclohexane, and then we'll worry about R versus S. So feel free to pause the video and draw the molecule, and when you unpause, we'll draw it together. All right, let's see if we get the same thing. So I'm going to draw cyclohexane. So we have our 6-membered ring, and bromine is at carbon 1, so I'm just going to arbitrarily pick the top carbon as carbon 1. And then chlorine is right next to that at carbon 2. Okay, so now we have to figure out how to draw this so that bromine, or the carbon that bromine is attached to, has an R configuration, and then the carbon that chlorine is attached to has an S configuration. So what I'm going to do is start with carbon 1. So I know that carbon 1 has to be in the R configuration. So I don't know if that means that bromine will be a wedge or a dash. So I'm just going to pick one and stick with it. So I'm just going to draw bromine coming up towards me. Okay. And then I'm going to check if that is the R position. If it's not the R position, then I'll draw it in a dashed form, because that will be the R position, if that makes sense. All right, so let's check whether this is an R conformation or an S conformation. So let's prioritize. All right, so let's see what carbon 1 is directly bonded to. So it's bonded to bromine, it's bonded to a carbon on the left, and then a carbon on the right. And then remember, there's a hidden hydrogen back here, which is the 4th bond that that carbon's bonded to. Okay, so if we're trying to prioritize these different bonds, which atom is the heaviest? Bromine, carbon, or hydrogen? Bromine. So bromine gets priority 1. All right, so what's next? Carbon or hydrogen? Carbon, but there's 2 carbons. So we have to figure out which carbon would have higher priority. So I'm actually going to draw the second carbon here in blue, and then we'll compare the two carbons. Okay, so the red carbon versus the blue carbon. So now we have to kind of go down the chain and figure out which atoms which atoms are directly connected to the red carbon, which atoms are directly connected to the blue carbon, and then we'll compare them and see which ones are heavier, which ones have the higher mass. So looking at the red carbon, that's bonded to a carbon down below, and then it's also bonded to two hydrogens. All right, so we have a carbon, a hydrogen, and a hydrogen. Now for the blue carbon, that's also bonded to another carbon. It's bonded to chlorine up here. And then there's also a hydrogen that we didn't draw because it's a bond line structure. Okay, so you can even start to cancel out atoms. So we have carbon, carbon, hydrogen, hydrogen. Okay, so now we're comparing a chlorine to a hydrogen. Which one is heavier? Chlorine. So the blue carbon will have higher priority because it's directly bonded to a heavier atom. So it wins the battle. Okay, so we'll label bromine number 1. We'll label the blue carbon number 2. And then that also means the red carbon is in priority 3. And then hydrogen is priority 4. Okay, so let's write that down. Okay, so now we can draw our circle and determine if carbon 1 has an R conformation or an S conformation. Oops. All right, so we draw a circle from 1 to 2 to 3. And that looks like if we imagine a steering wheel, we're turning it to the right or clockwise. Oh, I keep hitting next. Sorry about that. So we're doing a clockwise turn to the right. So is that R or S? R. So we just verified that bromine will be in the wedge position because that will create an R conformation for carbon 1. Great. Okay, now let's go over carbon 2. So I'm going to redraw the molecule. So we verified that bromine is in a wedge position, but we don't know if chlorine should be in a wedge position or a dashed position. So I'm just going to pick a dashed position, and then we'll see if that is correct. Okay, so now we're going to go through carbon 2's priorities. Okay, so carbon 2 is bonded to a chlorine, a carbon, and then a hydrogen that we didn't draw because it's a bond line structure. And that hydrogen will be in the wedge position since chlorine is in the dash position. Okay, so which is heaviest, chlorine, carbon, or hydrogen? Chlorine. Okay, then what comes next? Carbon or hydrogen? Carbon, but again, we have two carbons here. So let's label one of them as blue. And then we're going to compare the red carbon to the blue carbon again. Okay, so what is the red carbon bonded to? Well, it's bonded to another carbon. It's bonded to bromine up above, and then a hydrogen that's hiding back there. So we have bromine, carbon, and hydrogen. Okay, so what about the blue carbon? Well, the blue carbon is bonded to this carbon down here and two hydrogens. Okay, so let's write carbon, hydrogen, hydrogen. All right, so now we can start canceling out similar atoms. So each carbon is bonded to another carbon and a hydrogen. So now we're left with bromine versus hydrogen. Which one is heavier? Bromine. So the red carbon is going to be in priority 2. So let's start labeling these. That also means that the blue carbon is priority 3, and then hydrogen is priority 4. So let's write that down. Okay, so now let's draw a circle going from priority 1 to 2 to 3. Okay, so if we're imagining a steering wheel, we're turning it to the left or counterclockwise. So is that R or S? So that should be S, right? But hydrogen is our lowest priority atom, and it's in the front. So if your lowest priority atom is in the front, whatever assignment you think you have is actually the opposite. So normally here we would assign S, but hydrogen is in the front, so it's actually R. Okay, so what that tells us is chlorine is not in the dashed position because we want the S configuration. And we just determined that this is actually an R configuration. So when chlorine's in a dash, we have R, but we want S. So we're going to switch chlorine to the the wedged position. All right, so I'm just going to redraw this. So that chlorine and bromine are both in the wedge positions. Okay, so now let's double check that we have the right configuration here. So we already said that the red carbon is priority 2, the blue carbon is priority 3. So that still remains true. And now hydrogen is in a dashed position in priority 4, so hydrogen is now behind the plane. Okay, so now let's draw 1 to 2 to 3. So now our steering wheel is still going counterclockwise. It's still going to the left. So is that R or S? It's S. And hydrogen's in the back where it should be, so we can say that this for sure is the S conformation because our lowest priority atom is in the back, which is where we want it to be. Now, if we had wanted carbon 2 to be in the R conformation, then chlorine could be in the back. That would be fine because we already determined that that is the R conformation. But we wanted carbon 2 to be in the S conformation, so we realized, oh, chlorine has to be in the wedge position for that to be true. So when you're trying to draw molecules like this, where you have to draw R or S, it's really just a game of guess and check. So you can guess, okay, maybe bromine's in the wedge position, maybe chlorine's in the dash position. And then you go through, make your assignments, your priorities, you double check, and you might have to change some things in order to make that true. All right, so hopefully that helped a little bit with kind of seeing how we figure out when something is R, when something is S. All right, so this is our final drawing at the bottom. So again, bromine and chlorine are in wedge positions. Let's do one more practice problem. So I'm going to draw another molecule. So here we have 4 carbons, and carbon 2 and carbon 3 both have chlorines attached. So I would like you to identify any stereocenters. And remember, a stereocenter is an atom that's bonded to 4 different substituents. Then I want you to assign R or S to those stereocenters. Then I want you to name the molecule and determine if it is chiral. So remember, if something is chiral, its mirror image does not overlap with the original molecule. Or the other way to think about it is if something is chiral, it does not have a plane of symmetry. Okay, so pause the video, try to go through these 4 steps, and then when you feel that you're ready or if you get stuck, you can unpause and we'll go over it together. All right, let's go over this together. So where are the stereocenters? So let's actually label our carbons. 1, 2, 3, and 4. You could have also numbered them the opposite way. That's fine too. So using these numbers, which carbons are stereocenters? Or another way to ask that, which carbons are bonded to 4 different groups? Well, carbon 1 is not a stereocenter because it's bonded to 3 hydrogens and another carbon. So the fact that it's bonded to multiple hydrogens disqualifies it as a stereocenter. Carbon 2, however, is bonded to chlorine. It's bonded to a methyl group on the left, and then it's bonded to this big group off to the right, as well as a hydrogen that's hiding back here. So carbon 2 is a stereocenter. So we'll just mark it with an asterisk. All right, and then what about carbon 3? Is that a stereocenter? Yes, so it's kind of similar to carbon too, right? It's bonded to a methyl group on the right, a chlorine, and the atoms off to the left are considered another group. And then we also have a hydrogen that's in a wedge position coming out towards us. So that is also a stereocenter. And then what about carbon 4? Is that a stereocenter? No, it's bonded to 3 hydrogens and the rest of the molecule, but those 3 hydrogens disqualify it because they're all the same. All right, so now that we figured out where our stereocenters are, let's assign R or S to each of them. So let's start with carbon 2. We're going to figure out the priorities of each of the atoms that it's bonded to. Okay, so carbon 2 is bonded to chlorine up above, hydrogen in the back. It's bonded to this carbon over here and this carbon to the left. So which atom is the heaviest? Chlorine, carbon, or hydrogen? Chlorine. Okay, and then what comes next? Carbon or hydrogen? Carbon. But again, we have 2 carbons, so I'm going to label carbon 3 as blue. And now we have a competition between the red carbon and the blue carbon. Okay, so the red carbon, which is carbon 1, we already said it's bonded to 3 hydrogens, right? So we're just counting the atoms that are down the chain. So we'll just write out 3 hydrogens. And then what about the blue carbon? Well, it's bonded to the chlorine down below. It's also bonded to the invisible hydrogen that was in a wedge. And then it's bonded to carbon 4. Okay, so let's eliminate anything that's the same. Okay, so that's just the hydrogens there. So now it's a competition between hydrogen-hydrogen and then chlorine-carbon. So which carbon would win, the red carbon or the blue carbon? The blue carbon, it is bonded to heavier atoms. Okay, so we can assign chlorine as priority 1, the blue carbon as priority 2, and the red carbon as priority 3. And then hydrogen in the back is priority 4. Okay. All right, so now let's draw our little circle going from 1 to 2 to 3. All right, so if we imagine our steering wheel, we're moving it to the right in a clockwise direction. All right, so is that R or S? It's R. Okay, so carbon 2 has an R conformation, so we'll just make a note of that. Now let's figure out the other carbon. So I'm just going to redraw the molecule so we don't have all the mess that's up above. All right, so let's assign carbon 3 as R or S. Okay, so what is carbon 3 bonded to? It's bonded to chlorine down below, and then it's bonded to a carbon on the left, a carbon on the right, and then a hydrogen that's in a wedge position coming out towards us. Okay, so what would have first priority, chlorine, carbon, or hydrogen? Chlorine. So this is going to look pretty similar to what we did before. Okay, next we have carbon, but we have two carbons. So let's label one of them as blue. I'll label carbon 4 as blue. And now it's a competition between the red carbon and, oops, the blue carbon. Okay, so what is the red carbon bonded to? So it's bonded to a chlorine up above. It's bonded to a carbon on the end, and then it's also bonded to a hydrogen behind the plane. And then what is carbon 4, the blue carbon, bonded to? Three hydrogens, because it's a methyl group. All right, so we really only eliminate hydrogen again. So now it's a competition between chlorine and carbon versus hydrogen and hydrogen. So which carbon would win, the red carbon or the blue carbon? The red carbon, which is carbon 2. Okay, so let's assign priorities. So the blue carbon is priority 3, hydrogen is priority 4. So let's write that down. Okay, so let's draw our circle going from 1 to 2 to 3. So if this was a steering wheel, we're moving it towards the right in a clockwise direction. So is that R or S? So initially we would think that it's R, right? However, hydrogen is in the front, so our lowest priority atom is in the front. So it's actually the opposite. So it's actually S because the lowest priority is in the front. Okay, so that's a really important thing to remember. If your lowest priority atom is in the front, then your assignment is actually the opposite of what it appears to be. So even though we're turning the steering wheel to the right, because that hydrogen's in front, it's actually an S assignment. Okay, so we figured out that carbon 3 has an S configuration. All right, so I'm just going to erase these drawings, and I'm going to redraw the molecule, and then we'll name the molecule. And you can always go back and rewind the video if you want to go over some of those assignments again. Okay, so now let's name the molecule. So again, first we want to count our parent chain of carbons. So we have 1, 2, 3, 4. So which prefix would we use? Meth, eth, prop, bute, pent, etc. So we have 4 carbons, so that would be butane. And the ANE indicates that they're all singly bonded. Okay, now we have to name our substituents and indicate where they are on the chain. So we have two chlorines, so we'll name them dichloro. But we also need to put the locants or numbers in front of them. So we have one chlorine on carbon 2 and one on carbon 3. Now, one last thing, we have to indicate the R or S assignments for each carbon, or each stereocenter, I should say. So, the way that we numbered the chain, we would write 2R, because carbon 2 we said had an R conformation, comma 3S, and then we'd put a dash after that. We also put those R and S assignments in parentheses, and you'll notice that I put the carbon number in front of the R and the S. So carbon 2 is R, carbon 3 is S. Now, what if I had numbered this differently? What if I had numbered it 1, 2, 3, 4? Well, in that case, we would have named this 2S 3R dash 23 dash dichlorobutane. So are either of these more correct than the other? No, they're the same. Because this molecule has chlorines on the middle carbons, it doesn't really matter which way you number it. If you gave either of these names to somebody, they would be able to draw the same molecule, so it doesn't matter. So we'll write both are correct. All right, so now for the last question here, number 4, determine if the molecule is chiral. All right, so do we have a plane of symmetry in this molecule? Now remember, you can rotate the molecule any way you need to, and there are some single bonds there that can freely rotate. So what if we redraw this molecule? And I'm going to erase the names just to make some room. So what if we rotate this bond in the middle so that the chlorine on the bottom is actually on the top? Well, if we do that, our carbon chain will look like this, where the methyl groups are pointing down. And then our chlorine on carbon 2 is still a wedge. But what about the chlorine on carbon 3? Will that still be dashed if we rotate it up? Nope, it'll be a wedge when we rotate it. And I encourage you to build the molecular model of this using your modeling kit. It will be much easier to see that when you rotate that bond, chlorine will become a wedge. So it will actually face out towards us. Okay, so now looking at it this way, is there a plane of symmetry? Yes. So there is a plane of symmetry down the middle. So is it chiral? No. So it has a plane of symmetry. So it is achiral. So remember, if something does have a plane of symmetry, it is not chiral, it is achiral. All right, so hopefully this helped understand how to assign R and S. We also got some practice with naming. And we also got a little bit of practice with determining whether a molecule is chiral or achiral. Now, the molecule that we just drew is actually called a meso compound. Okay, so a meso compound is a compound that contains stereocenters, but it is achiral due to an internal plane of symmetry. So sometimes you need to rotate the molecule in order to see the plane of symmetry. So for instance, with the molecule we just looked at, it was really hard to see that there was a plane of symmetry there because it didn't really look like it. But if we rotate one of the bonds, and again, if you have all single bonds, the molecule can, the molecule can freely rotate anyway. So if we rotate it, we see that there is in fact a plane of symmetry, even though it has stereocenters. So this is a meso compound. So actually in our greener bromination of stilbene lab, the product is also a meso compound. It has a plane of symmetry. So I encourage you to go look at that and try to identify that plane of symmetry. Okay, so in the next lecture, we're going to talk about how to determine if a molecule is chiral using laboratory techniques. So we're going to talk about something called a polarimeter. So I will see you then.